Hey, what's up guys? RJ here, back with another video. This is the second episode in a series I'm calling Practical Prints, where I take you on a journey, if you will, a trip from inception of an idea or need all the way through to the finished product. On these journeys, I'll try and share my work and thought processes and hopefully answer the what, how, and whys along the way. In this episode, we design, build, and strength test an adapter for the very popular 717 fluid head. It's sold under the Cowboystudio, Weifeng, Fancier, I believe E-Image, just to name a few. The purpose of this adapter will allow me to use the affordable quick release system related to the 717 on all my camera gear, my cages, slider, my other tripods. Makes it much easier to get the camera gear on and off with the quick release system, and it's very affordable. Are you ready? Let's get started. Welcome back. I've already mentioned the what and the whys for this project, so let's look at the how. Using Fusion 360, a 3D printer, some ABS filament, some supplies from the hardware store, and a lot of trial and error, I was able to solve the need, and in the end, I found success. It took me 7 iterations to finally get everything just the way I wanted it, which brings up another point. Don't be afraid to fail. It may get a bit frustrating at times, but it's an extremely important part of the process. As long as you learn from it, it's not a waste in my opinion. So you're going to need a caliper, preferably a digital one, some paper, and a pencil. I start off sketching a basic outline, just jotting down some measurements. While I'm measuring to see how symmetrical this plate was, I tried to think how I would lay it out in Fusion. What would be the best way to draw it out in Fusion? Sometimes when the project's really easy, I just completely skip this step and move right into Fusion. Once I have the basic sketch and measurements down, I then move back into Fusion. Before I start, please keep in mind I am not an engineer and have no formal training in design or in Fusion 360 for that matter. I've learned from websites, I've learned from messing around with the program, asking questions on forums. Speaking of training, I want to give a huge shout out and a big thanks to Noah Ruiz, I hope I pronounced her name right, over at Adafruit. I can't thank him enough for not only turning me on to Fusion, but for his countless hours that he's invested into his layer by layer series. You guys need to check out his series. I'll leave a link in the description. So anyway, what I'm trying to say is I'm pretty sure there are many different ways, and most likely better ways, to accomplish these tasks. So let's take a look at the completed model for a few seconds and talk about some design considerations. For me, I find myself thinking about how the object I'm designing is going to be used, what forces are going to be placed upon it, and in what direction. In some cases, such as this adapter, there's typically just 1 or 2 major considerations, and in particularly strength in this one. Strength is the most important part of this design. It would be a huge problem if that mount broke and my $1,000 camera hit the ground. So it's very important to design, redesign, and test to make sure, especially in the case of a functional part, that you have it right. So as I see it, there are 2 very high stress points in this design. The first high stress point is at each of the 4 corners of the bottom plate. I thought about using a bolt and nut to kind of clamp the plate to the adapter, And this would have worked just fine, but it wasn't clean enough for me. So I decided to use these little M486 knurl inserts. It provides a nice clean solution, but it also introduces a problem. Normally these nuts are sunk into the plastic by heating them up with a soldering iron in my case, which in most cases isn't a problem. However, under high stress, the knurls can pull themselves out of the plastic, and I can't have that, or else it might break loose of the adapter, and then of course again, $1,000 camera on the ground, bad. So the solution was to insert the knurl nut from the bottom. So the hole for the M4 screw would be smaller than the hole that the nut would be sunken into. This provided several millimeters, roughly 7 millimeters, of plastic that would resist against the nut and keep it from pulling out. The other or second area is the center mounting point. This is another high stress area. This area is where the force of the T-nut will pull down on the plastic adapter. So this is where you would attach it to a slider or a tripod or a cage. So there's a bit of force also on that center area. So this area is somewhat easier to deal with, especially when using the larger 3/8 T-nuts. So there just needed to be a fair amount of plastic there, strong enough to keep it from breaking apart, but thin enough that I could fit the adapter inside of a cage, which sometimes are smaller and don't allow a whole lot of height. Okay guys, so we're now in Fusion, and as you can see, this is the completed model. Took me several days of trial and error here. And again, I want to remind you that I'm new to Fusion, just learning my way around it. Fairly new to design in general, so I'm sure there are better ways to do what I'm about to do. So there was a YouTube user by the name of Extrude who had some great suggestions, and one of those suggestions was to maybe go over the shortcut keys or the shortcut functions, keyboard functions that are found in Fusion. So it turns out that there's not a system within Fusion that will bring up a list of these shortcuts based on the keyboard. So I did a little search and found this, and I think it is fairly up to date. So as you can see, there are a few keyboard shortcuts, probably not as many as some would like, but it's got your basic sketch type of tools like the circle tool, the line tool, offsets, trims. So I'll try to leave a link in the description where you can find this. It's fairly helpful. So anyway, so let's get to it. Now, obviously I don't have enough time to go over every detail of this drawing. It's pretty basic, so I'm going to try to show you the basic functions that I used in order to come up with this. So some of it I'm going to try to be pulling up from memory. Some of it I got down pretty good. So just bear with me through some of this. Alright, so let's start. Oh, and if you hear some noise, if you're hearing noise, it's my printer going in the background. So sorry about that. Okay, so let's start a new design. And we will use the rectangle tool. You can use the keyboard R,
shortcut or go up to sketch and go to rectangle, and you have several different kinds of rectangle. I'm going to use a 2-point. From here you need to select the plane to work on. So I'm going to start on what I call the floor plane, the bottom plane, and that's typically where I start my design. So you click on that, and then I'll usually use the center point right here to start. So you can either click on your mouse, or you can enter the dimensions, and it will draw the rectangle and dimension it all at the same time if you choose to do that. So we're going to go with the first dimension, which is our width, and that's 6320. You hit enter, it will move to the next dimension. In our case it's 7940. Hit enter again, and there you go, it dimensioned and placed the rectangle. So I always like to start my designs via sketches, so that way if I need to make a change, if I need to move a hole or move a feature, I can do that very easily in most cases just by going back to the sketch and changing it. So the next thing we're going to need is 4 holes. So we can again either hit the C key on the keyboard or go up to the sketch menu and select circle. And I'm just going to I'm going to throw these right here for now. And our circle is going to be, it's 4 millimeters, but because I'm printing in ABS, there's going to be some shrinkage, so I'm going to make them a little wider. So I'm going to go 4.22. Hit enter, and there we go. We've got our circle and a dimension. Now, you can mirror these to each of the planes, but what I found when I sketched out the plate is, surprisingly, the holes are not exactly in the same location in the aluminum base plate. Okay, so now we got our 4 circles inside of the rectangle. We need to dimension them to get them where we need them within this area. So what I typically do is I try to reference one side of the object, if at all possible. And so we'll come up to here to the dimension tool that I've placed here. Now I believe it is also found under sketch and sketch dimension. So select the center of the circle and select this reference or this edge, and in our case we are on this side 11.10 millimeters, and then we need to dimension it to this side, which we are 6.18. There we go, 6.18. Okay, and so you would just continue to do that for each of the holes. Okay, so now we have our 4 corners, or now 4 holes in our plate. So the next thing we need to do is draw out these areas on the plate that are raised. So we'll go ahead and add our one dimension here. So let me move this over in the middle here better. So we can use a line tool to mark out our areas for the edge. So I'll go ahead and hit the L key on my keyboard and just do a rough sketch here. Alright, and then another one over here. This side's a little different. Oops. Alright. So that gives us a rough area to work with. So you can hit the escape key to get out of the line tool. So from here, it's all about, again, dimensioning this area. So you need to measure out the constraints from this, say, this edge to here, and from here to here, and you want to line it up with what you drew or are actively measuring on the adapter plate. So from here you can, now we know that these areas are raised on the plate, so it is this area that will get extruded upward. So what we can do is just click and then right click on the area that you want to extrude, select the extrude command, and then extrude up as far as you want. Now in this particular design, I can't remember exactly, but we'll do 15 millimeters. So as you can see, there's a problem in that there's no base in this area, and we need to have a base. So the great thing about Fusion, and really any parametric design tool, is you can go back and change in time the features that you made. So in this case, we need to extrude this area up, but we're going to do it in another process. So we'll just hit complete. We'll go back to the sketch, and we'll now extrude these areas. And you can select both by holding down the shift key and then selecting the other. Right click and extrude, and we'll extrude these up, we'll say 5 millimeter. And now that gives us a base. Now, one thing I did not talk about, and you can see that what had happened was it created 2 additional bodies, and we really don't want that. We want to combine those bodies. So what we can do is, again, go back in the timeline here, double click, and change this operation from new body to join, and then hit OK. So now we have 1 body and not 3. So I think from here, I'll show you how to sketch another facet or face on the surface. So in this case, we need to remove some of this area here, and what I did was I just selected the face, right clicked, and then selected create sketch. And what that'll do is it'll create a sketch directly on top of that area that you selected. So in this case, I'm going to use the circle tool, and I'm going to find a spot just for purposes of this demonstration to select. I'm going to escape out. So now what I can do is I can extrude this little area that I need removed, and I'll go downward, negative. And what that will do, it will automatically select the operation as a cut. Hit OK, and as you can see, it removed it from the edge. And basically that's all I did for creating this part. I just went back and forth creating each of the features that I needed, and ended up with this. Now, these corners, as you can see, are sloped, and how I did that was, let me show you the timeline. I created a sketch on the edge, used my line tools, and just simply lined off that area so that I could extrude, just like I did that circle, this area away. And let me show you. Right here, I believe, is the operation. And as you can see, I just extruded them to the distance that I needed. So what else? Fillets here. So I wanted to, I didn't want it quite square because the plate isn't quite square. It's got a small radius around each four corners. So that's a very simple operation in Fusion. Let me see if I can go back to it. It's probably one of my later. There it is. So all you need to do is select the corners that you want to fillet. Let me get out of this and just show you. Let's just say I want to fillet this edge, round that edge off, and this edge. So select the edges again. You can use the control key, or I believe also the shift key, yeah. And then select one of the edges, choose fillet or chamfer. In this case, we're gonna fillet it. Now you can use this little arrow to do it, manually, or you can enter the amount here, and we'll just say 1 millimeter. And that's all there is to it. Really, really easy. So in this case, we don't want fillets, and the reason why there's no fillets anywhere other than on the outer edges was because I needed the plate to sit in tight. I didn't want very little movement in this design for the plate. So when the plates sit in here, it barely moves, like maybe a millimeter or two. So that's that. So what else? Yes. So as I said before, using the knurl nuts that you melt into the plastic, if I were to just melt them into the top section here, what I was trying to explain was, so the screw comes down through this orientation, and so the knurl would be sitting up right here. Well, under high stress loads, that when you're tightening it down, or if the camera's bumped or something pulls on the camera really hard or whatever, those knurl nuts have a tendency to pull out of the plastic. So what I did was I went, and let's see if I can get a view of this. I went on the opposite side, so this is what I call the bottom of it, of the adapter. And as you can see here, I widened this area to accept the knurl nut, and I made the diameter on the top 4.22, which is just a hair with the shrinking of the ABS and my printer, it fits the screw pretty good, pretty tight. A matter of fact, almost a little too tight. But what that does is it creates an area. Let me use the inspection. You can go to inspection and section analysis, select the plane that you want to analyze, and it'll pop up a little pull arrow here. So what this does is it creates this edge that the knurl nut will rest against as you sink it down. So it would take a tremendous amount of pressure to pull that knurl nut up through 7 millimeters of plastic, and it's really strong. So the only breaking area would be is if at that layer it broke in the plastic, and then the whole thing would just split and come up. So yeah, so that's that. That's how I designed that. What else? The section here, let me cancel out of here. So what I wanted to make, I wanted this adapter to fit both 3/8 and 1/4 inch like tripods or cage mounts. So in order to do that, I had to went to the hardware store and again got those they call them T-nuts, and they've got those teeth that stick in most of the time wood. That's what they're primarily used for, but they work perfectly here because the 3/8 T-nut sits, because it has a higher base to it, it sits a little higher. So I had to make this a little higher than the 1/4 inch. And of course the 1/4 inch doesn't have that tall base on it, so it sits a little lower. So it's just, I just staggered the levels here to accommodate the different T-nuts. And you can see that in the drawing here. Let me get to it right here. And basically just measured off each section and then extruded accordingly. Let me see if I can find the extrusion here. Here we go. So you can see this was the first extrusion. So I extruded downward, removing the material to the width of or the thickness of the T-nut, and then I just simply did it again to this one. All right, so I think that is pretty much it. I don't really want to make this video too long. So basically that is the rough tools, rough way of using the circle, dimension, line, and extrusion tools in Fusion 360. Oh, and the inspection tools. There's a bunch of features in Fusion. Way more power than I need. Alright guys, so until next time.
So now with the print completed and the supplies gathered, we're ready to assemble the adapter. You're going to need a soldering iron to set both the knurl nuts and the 1/4 inch T-nuts. Now for the 3/8 T-nuts, you're going to need a small torch. There's no way that you're going to be able to sink that large T-nut with a soldering iron. A cooking torch should even be hot enough with that small flame to heat the T-nut up just enough to melt it into the plastic, but not burn the plastic around it. Sinking the knurl nuts into the plastic is fairly easy. You just need to make sure the filleted end of the knurl nut faces the direction that the screw will enter the nut through. Go slow, let the heat do the work, and sink it in as straight as possible, trying to keep it from rocking, because if it rocks, it will loosen the hole that the knurl sits in and won't be in as tight. Now in this particular case, because we are installing the knurl nuts behind 7 millimeters of plastic, it's not as critical. But in other cases where you'll be pulling on it from the face that you're sinking it into, it's very important that you keep it in going straight. So I wasn't exactly sure how to properly test this mount with what I had on hand. So in this next segment, I'll show you one of my tests. I was hoping to get to another test, which basically I was going to take the same kind of feature but that you'll see in the video, but instead of using the workbench, I was going to use a cinder block and then drop a mallet on it, 7-pound mallet on it, and see how it reacted. But I didn't get to it. Maybe I'll do that as a follow-up video. As you can see, it looks like, or hopefully you can see, it looks like the wood on the bench is actually pulling up. Alright, let's bolt this down a little tighter. I'm actually pushing the washer into the wood. Actually broke the bench. So that's pretty strong, that adapter. Well guys, that's a wrap on this one. Overall, this was one of those projects where everything just came together and functioned just as I desired. If you have any questions about this project or ideas of how I could have done it better, leave a comment. If you found this episode helpful, slap a like onto it. I've got some very exciting things on tap for my subscribers, so be sure to subscribe if you're not already so that you'll be notified of the future videos. I'm going to try to do at least one video every 2 weeks, so you won't want to miss my hacking shenanigans. Also, sometime in June, there's going to be an announcement. You're going to want to stay tuned for that. There's going to be a collab with another channel that I think you're going to be very interested in. Okay guys, until next time, see ya.